Hello friends, as part of this discussion, we'll try to understand clustering in machine learning. So we'll try to understand the clustering techniques. We'll see some Python examples, how we can perform clustering. Uh, but first of all, what is clustering? Clustering is an unsupervised machine learning technique used for grouping similar data points together. So it's an unsupervised machine learning technique. It helps us to group similar data points together. And why it is important? It helps us in pattern recognition and data segmentation. There are various applications of it, like market segmentation, anomaly detection, document classification, etc. There are various clustering algorithms available. Some important ones are mentioned over here. If we look different methods like partitioning method, hierarchical method, density based method, and grid based methods are the popular ones. If we talk about K-means clustering is the most popular clustering algorithm. It divides data into K clusters based on distance from centroids. It's an iterative approach to minimize intra-cluster variance. Other techniques like hierarchical clustering, it builds a tree-like cluster hierarchy. And another one, popular one, DB scan clustering. It's a density-based clustering method. It can detect clusters of varying shapes. So choosing the right clustering algorithm is very important based on the data sets and based on the requirement. We need to choose a specific technique. So K-means basically helps and works well for spherical clusters with similar sizes. Hierarchical is useful for understanding hierarchical structures. DB-scan is good for discovering clusters of varying shapes and noise handling. So we'll see some examples and then we'll see the performance of basically how we can evaluate the performance of different clustering algorithms. So let's get into the Python code. So if you look at here from scikit-learn, we have this k-means clustering method available basically, and using this we can basically see different clusters. So this is an example data set and we can create different clusters using this. If you look at here, this basically gives you different clusters for this data set. So let me restart the kernel. Yeah, so these are the clusters, different cluster for this data set. And then we can visualize using these methods and techniques, like you can refer to these examples. And then about hierarchical clustering, we have these examples ready. You can play with this code. And DB scan clustering example is also available here. And then how we can evaluate. So we were discussing that how we can evaluate different clustering how to evaluate the performance of different clustering techniques. So there are some methods. Popular one, elbow method. It basically helps in determining the optimal number of clusters, and it basically uses inertia. So we'll see that examples here. Like if you see this example, the data set we have created. So we first using k-means we have created the clusters. Now we are seeing that what would be the optimal cluster for this data set. How many clusters basically we need to create. So if you look at this elbow method, so after 4 cluster, 1, 2, 3, 4, this is getting flattened. So that's how we know that this is an elbow kind of shape. So that's why it's called elbow method. So after 4 clusters, if you see, this has become very flattened. So this is where we need to stop. This is the optimal cluster number for us for this data set. So that's how we understand that 4 cluster is the optimal one for this data set. Moving ahead, so there are other methods like Shilhoughty score, Davis-Baldwin index. So you can refer in internet, more details would be available. Now, application of clustering, we already discussed about this. Most popular ones like market segmentation and anomaly detection. Also, clustering helps in anomaly detection, especially in fraud detections in banking. And we can do document clustering. We can do image segmentation using clustering. So in summary, clustering helps in discovering hidden patterns in data. Different algorithm suits different data distributions. K-means is most widely used, but it has some limitation as well. Hierarchical and DBs can provide more flexibility, and clustering methods is essential for data analysis. We should know that because in many of the cases we have unsupervised techniques which comes into play when we don't have data labels available. So clustering is very important in those scenarios where we don't have data labels available, but we wanted to understand the segments. Let's say we want to understand the data patterns. So then clustering helps us. So the code examples are available here, so you can play with this. I'll provide the link in the description, so you can go through all this code and check yourself. It will improve your understanding. Okay, then let's conclude this discussion. Thank you.